Hi, good morning. Thanks so much for joining me here in my shop. Today is March 30th, almost the last day of March, and I have the car radio back in my shop here on the bench. Now, my last video on this radio, the very end of that video, I was out in my garage giving this radio a test, and at the time I think I was kind of okay with it, but afterwards and thinking more about it, I think I can do a little better. I think we can get a little more out of this radio. The indication that something wasn't quite right was the inability to pick up a particular station at 590, which is the strongest AM station in my area. It's coming from Toronto, about 150 kilometers away. I think that's where the transmitter is. And usually I can pick that station up before any others. And then a weaker station that I like to use to test radios, about the middle of the AM band, is 860, a French station. Which I don't know where it comes from, to be honest with you, but probably a little further away. So I could pick up the French one on this radio in my garage, but not the sports channel at 590, which I think is curious. Which suggests to me, right or wrong, that maybe the alignment didn't come off as good as it could have. And also I broke one of my, I wouldn't say cardinal rules, but one of the things I know about this work. I know about me and this work anyway. And that is, the first time I go through an alignment process, it really makes sense for me to just write it off as education, learning about the radio, the procedures, and all the little intricacies and problems that seem to exist in every radio I work on. I only did one pass through of the alignment here, and kind of settled for that. I think that's a bit of a mistake. So I'm going to do it again. This time I'm going to throw more equipment at it. I'm going to take a little bit of a different approach here and there. See if I can't recover the radio's sensitivity right across the band and get it working a little bit better. So that's what I plan to do. I don't think I'm going to do the IF. I think that's probably fine. It's really the RF alignment, and in particular these three coils here with their moving inductors inside. I struggled with trying to do the alignment process here. The first step is to do a distance measurement on this one, and that's where you start. I didn't bother with that. My assumption was, well, it's probably where it was from the factory, and it's probably okay. And it looked like that distance measurement was really tricky to make, but I'm going to look a little more closely at it, see if we shouldn't try to do that. And then the other two are essentially being aligned against this one. I think that's kind of how it really works out in the end. So the final, some of the final alignment steps were done at 1,000 kilocycles. That's just a little ways away from that French station. So is it possible I simply align the radio successfully in the middle of the band, but at the ends, or at one end anyway, the lower end, it's just not doing the job? So I want to find these things out. It's not easy to be sure about any of this kind of stuff, especially here in my shop with so much noise in here, noise that is much stronger than the radio stations. Sometimes I'm shocked when I finish a radio in here. I'll take it outside, right outside, and I'm stunned at how well it works compared to in here, where it's just picking up whirs and buzzes and hisses and clicks and all kinds of other stuff. So that's what I'm going to do today. We'll see how that goes. Okay, I think the place to start is by looking very carefully at the first instruction on the RF alignment. So the RF alignment starts here at step 2. And the first instruction is hidden in this asterisk. Come down here and read it. What it says is, before making this adjustment, which I ignored this, before making this adjustment, check mechanical setting of oscillator core H. Oscillator core H. So here we see it's right here. It's the center one of those three ganged together adjustments that move when you tune the radio. With the tuning knob, the rear of the core should be 1 25/32 of an inch. This is such a precise measurement. from the mounting end of the coil form. And then to make you feel better about it, they suggest this measurement is readily made by inserting a suitable plug in the mounting end of the coil form. Core adjustment should be made with an insulated screwdriver. Why is that? Like, why would it matter? You're doing this based on a measurement. The radio doesn't have to be on to do this. Core adjustment. Well, maybe this is a more, this note probably applies to the adjustment of F and C. That's probably really what's going on. Wait a minute. This is E, F, and C. Well, this is H. Yeah, so this note generally applies to all this. E, F, and C. I can't remember what those were. Those were E, F, and I figured out this to be G. E, F, and G. So it's just these, right in a row here. Okay, just making sure I've got a grip on this. Before making this adjustment, check the mechanical setting of oscillator core H. How am I going to measure this? What are they talking about? A plug. A plug. If they said probe, I'd kind of follow this a little better. Inserting a suitable plug, I would say probe, in the mounting end of the coil form. And what do I mean by suitable? Suitable plug. Not just any plug. Okay, let's take a look at this. What I believe they're talking about here, which is the rear of the core should be that far from the mounting end of the coil form. Sticking in or sticking out? I thought it was in, because they're sticking out of the other end of the core. Okay, let's take a look at this and see what we can sort out. Okay, maybe just to explain myself a little bit further here. Why am I reading those few words over and over in the instructions? I'm trying to parse them. I go one word at a time and spot things, and because the writing in those instructions is very efficient. Efficient for the writer. He's trying to use as few words in his instruction as possible. He literally doesn't want to write a book. Look, I just acquired this book, Elements of Radio Servicing, which I'm pretty excited to read through. So this book is inefficient. It's terribly inefficient. Look at how thick it is to cover the topic. There's lots of books like this. Very inefficient. Using lots and lots of words to get messages across into my head when I read this book. I find that fantastic. In this case, the writer has taken on the responsibility of what he's sending into my head. It's he's taken on the problem of getting it into my head. I should have an easy time reading through a book like this. I like these older books. This is from 1955. It was the last year published. I have a much easier time reading these books than more modern, more efficient writing. And an example of which is the instructions for doing the alignment on this. They're extremely efficient, very few words used. But it becomes my problem to figure out what the writer is saying when that happens. So I'm painfully aware of this. You really, like there's two ways of looking at this, right? It's either the responsibility of the reader or the responsibility of the writer to get the message across. And I've always believed it's the responsibility of the writer, or the speaker, like I'm doing now, to get the message across. It's easy to write and speak efficiently. What's in your head as the speaker can be quite complicated. You're just throwing out a few words on the assumption that those who are listening or reading are going to be able to figure out what you've got in your head. It becomes their responsibility. And a fantastic example of this is things like modern communication, like Twitter and these other systems where you use very few words to get your message across. kind of cross your fingers and hope people will absorb it the way you intended it. And I think that's often not the case. When you use very, very few words, the reader is free to make all kinds of assumptions and errors in what is being said, to take the message and basically land it comfortably into their heads, because they're left alone with the message, because there's not a lot to it. Whereas in a book like this, where, I mean, this is just, elements, basics of radio servicing. Yeah, and this 1955. I mean, if you were to write this book today, it would be this thick, plus all the new technology that's come along. It would look like this. Oh my gosh, who would read it? Who has the time to read stuff like that in today's world? Too busy watching stupid 5-second videos on YouTube and other idiotic pursuits of humans these days, including me. So anyway, that's a little speech about communication and how I view it. And when I'm doing this work, I'm thinking about stuff like that. That's why I reread that little bit again and again and again, to look for any little hints the writer has put in there that may not be obvious to the first time read. And, that kind of goes along with this whole alignment thing. That first time through, as I say, you can write it off to education. That's a general rule in my life. It doesn't matter what it is. It's not just aligning radios. It's anything. Maybe the first 5 times through, in fact, can be written off to education, which means you shouldn't feel bad about things not working out when you're new at something. You shouldn't feel bad about that. You're paying the price for education, your own self-education. Wow, pretty speechy this morning. Okay, now in reading it, let me switch to the other camera here. We'll get a little better view to look at this. It sounds to me they're talking about this center. This is H here. They talk about the. Let me get it on the screen here and get the words right. Just on my own screen here. The rear of the core. So the rear. So I would take it this is the front of the radio up here, and the rear, the front of the radio, the rear of the radio. This got to be the rear of the core. I would say it's got to be the case. Should be the rear of the core, and now they're talking about this little piece right here that I'm pointing at. This is the core part right here. This brown thing is the form. Okay, I mean, if you've done lots of this, you know all this. I mean, not telling you anything new at all. But if you're new to this, well, there are certain words that are used. That's part of the efficiency of the writing. Because they could have said the core, which is a paper tube or cardboard tube, will usually have a brown color, and go on about it. End up with that thick book doing that. Core should be 1 in 25-30 seconds from the mounting end of the coil form. The rear of the core. So this must be the front of the core. The rear of the core is up inside here. Or is it protruding? Can't really see for sure. Exactly where is the end of the core? So I see here, when I look at this, I see some rubber mounts here. Funny, this one's a different color. So these are rubber mounts holding what I assume is the rear end of this thing, partway inside here. So I don't think, well, maybe it's flush. Maybe it's flush here. How are we going to see that? Wouldn't it be kind of a coincidence if it's flush? I think they are. I think they're completely flush with this rubber mount. I think I can see them right here, flush with this rubber mount. Okay. So couldn't I stick something up in the core, the probe, and then mark it, and then take it out and measure it? Or better yet, why couldn't I take a probe of some sort and mark it? stick it in and look in here and see. Okay, let's stick this in there and see what happens. Now, you know, the problem with the core is it's a slotted end. Oh my gosh, it's going a mile in. Of course, the radio's got to be tuned to, I'm looking at the pointer here. Actually, that's quite a distance, isn't it? 1 in 25, 30 seconds. So 25, 30 seconds, roughly an inch and a half. Okay, I think we've reached the stopping point here, which was a little bit, ooh. I'm oohing because I can see that when I pull on this, you know, the rod is, this bracket is just moving at this end. That means the relationship between these three is changing. But there's something pulling it back, like a spring. There's a spring right down here. That's probably making sure that it settles into place. Yeah, either one. So this is springing back onto some kind of a stop. These pieces right here are hook shaped. You can see this one. You can see a bit of a hook of it, and then there's a rod extension, a screw or rod, something screwed into this fitting here, which is inside there, and that's where the play is that we can hear, because this piece isn't moving. This hook, not moving. Okay, so we just want to make sure that's all settling in, and it is. There's some, it looks like this is all solidly done. I guess the adjustment of any problems in this, and the compensation is the adjustment of these guys, which I'm trying to do. Okay, let's just do a rough one now. I was saying that when you put in the probe, it goes all the way up. It meets the end of the rod, but the end of the rod has a slot in it. Well, are you supposed to sink your tool into the slot? I would say not. Okay, so just, you know, okay, I'll tell you what, from here, I can go like that. You can see the end of this is way up, must be just about entirely out of the coil. That we can't see the coil in here. You can actually see the coil wires right here. But I don't want to touch them. There's another one here and another one over here. They're very, very fine wires. So I think I can actually see the bottom of the coil right in here. Not sure what I'm seeing. You know, at this distance. So assuming you don't go in the slot, you put anything up there. We want to mark that. Pull it out. Let's get something and try this. We'll try this. Something I can mark. I have to be an awfully precise mark. Let's just see. Do I have a ruler that has 30/2 of an inch on it? Here's a ruler. It's a little hard to see, isn't it? Let's just look at it with some sandpaper behind it. Here we are. Look, from here to here, it's in 30/2. It says right on it. So that's the size of the markings there. So we're going to say, again, let me look at the sheet to be sure it is 1 and 25/32 of an inch. So if I had a mark on the stick, what would I do with it? I would want to line the mark up with the number 2 and then count 25 divisions. Okay. Okay, let's give this a go here. I can do this again and again. It's no big deal. I have lots of sticks. Go in there. There we go. I'm going to mark it with this. No precision here the first time through. It's again a 32nd of an inch. And you probably can't see this. It is it's really tiny. Of course. Okay, I got a mark on there. It's not much of a mark. Oh yeah, I can see it pretty clear. I managed to shove the pen up. So I really think the leading edge of this mark up here is correct. Okay, let's take a look at the measurement here. I have to count to 25 to do this. Okay, so I got this lined up on the 2. And we're going to count. Well, luckily they're in bigger gradations. So we're at 16 here already. 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, right on the button. Let's try that again. Sometimes my hopefulness can overwhelm us. So you got a good view on the camera, just looking up at my TV. Okay, we'll try it again. So this is 16. 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Okay, if I wanted to line the end up, it would move that much. That's literally half a division. That's 1/64th of an inch. And I gotta wonder how accurate my dot was. Well, that's pretty darn good. Seems to match the instruction. So I gambled the first time through on the assumption that this was set in the factory and done properly, and no one's ever touched it since, so why would it be any different? It's all mechanics. All assumption. Okay, so I can put this in. I can simply look at the dot. Let's get this really close. Let me just adjust that camera and get really close. Okay, I think that's got the edge of the form in view. Put in my pointer, my stick, my probe. Probe in. And we're looking for the mark. Where's the mark? There's the mark. Well, it looks like it's right on the money. The one edge is right on the money. Just make sure the radio is tuned all the way possible. Yep. Well, I managed to get that mark right on the money. Okay, now with the camera looking really close, got some sandpaper here. I'll repeat the measurements. I'm going to set this up so the 2-inch mark is right on that same edge of the mark I made. There it is. And we'll count again. 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. I get 26 out of that. 26 out of that. It's rotating here. Doggone, I think I moved it. The stick is warped and it wants to be a different way on the way I'm holding it. Just see if I can just settle it down. So if we go over here and look at the mark, okay, a little parallax error in the camera, but I can see it straight on. The mark is lined up right with the number 2. Oh my gosh, this is like didn't we learn about rulers in grade 3 or something? So when I was in grade 3, the Canada was changing from the imperial system, the British imperial system, to the metric system under an agreement with the United States. And I remember to this day the teacher saying to us, apologizing, this is going to be a difficult transition for people to make. And really, not for us students. Didn't know any better. She was talking about herself. So look, I'd say it's off by 1/32. That's what I would say. And what's that mean? That means that it's too far in. The stick is too long. It's too far in. It needs to be moved back a little bit. This is probably within the range of error that it was being done in the factory, I would guess. But you know, they don't talk about 16ths of an inch. They talk about 32nds of an inch. Let's try it again. Try it one more time. Okay, watching this mark. Looks like I just keep cutting in the same spot. Okay. Maybe I just didn't angle the knife in sharp enough. So I'm trying to mark where it is now. We should end up, see that dark stuff, maybe that's the hard wood. Let's put it here. Okay, sliding the knife over, getting all the angles right, stick is in place. And hack. There's a mark. It's different than that one. Okay, so I got the new mark for sure on there. This was 24. Oh, it's off the camera. Oh, it looks exactly the same. It should be one past 24. One past here. Let me just check and make sure I've got this on. Oh, I don't have it right. Not lined up with the 2. Now it's exactly lined up. A little parallax thing was happening there. Wow, okay. We are there. I'd say that's it. Okay. There we go. How much difference could that make in this radio? I just can't imagine it could make much difference at all. But it's done. Well, we know. We know now it's in the right place. Right enough. Oh my gosh, this is what, half an hour to get that done? Or more. And 12 o'clock sharp. So I think I'm going to stop, have a little lunch, and then we'll redo the RF alignment and see what happens in the end. Yeah, I really hope that this will really pick up. Not this little adjustment I did now, but I think the rest of it didn't go well. Did I say anything? Maybe I didn't say anything. Clearly, when I was adjusting this, I ran into alignment issue number 3. Which is where you take your tool and you turn the thing one way, but you can't turn it back the other. It just wants to go one way all the time, and you get further and further one way, but you can never get it back, and that's the struggle I had with this one. Don't know if I made that clear while I was doing it. Okay. It's lunchtime. Actually, before I go for lunch, I never really finished off that metric conversion story. So Canada and the United States had agreed to do everything together, so we would change especially speeds, and like we'd switch to kilometers, so all the speed signs would have to change and all that kind of stuff. And Canada got all ramped up and started doing the process, and the Americans got cold feet and just stopped. And so we carried on. We did everything. We even used regulation to force things like butchers to do weight in kilograms and things like that. It was actually difficult for a lot of people, older people in particular, to make the switch. Today, if you go to the butcher shop, you can buy your meat in pounds again. People don't seem to care, but we're fluent now in both systems. Although younger children might have a little bit of trouble with knowing what an inch and a foot is, because it's really kind of gone away. But the Americans, on the other hand, chickened out And that's why the Americans, except for the scientific engineering community, which went to metric because it makes the math a lot easier, everybody else is still running around following a British system. Even British people don't follow it anymore. Come on, United States. Okay, I think I've got things ready to go here. I have a plethora of tools here, but really the only two I can really use are these two, which are pretty much the same thing, except one has a handle on it. It's the same flexible stuff. So we're going to use the handled one, the one I used before. I'm going to switch on the power here, and the radio is, whoops, I'll move this all the way to the end. I have a mirror so I can look at the dial. The radio is switched off for sure. This is the pickup coil for my SDR radio, which I'll be talking about once we get going. I'm just going to set it off to the side. And I'm going to reach over and switch on the power supply. Making sure positive is positive. And we don't have any, it's just a remote chance of a short developing over here. I wouldn't want that to happen. Okay. Power's on. Switch on the radio. No, not with that. I have the radio turned upside down, so it's that's all it takes. There we go. No antenna connected, but I do have the input from the signal generator right here, and I've shortened up the connections. Then, as opposed to what I had before, there's that familiar buzz. Let's see what happens when we turn it up. Very good. Again, there's just a ton of volume here. We should be all the way up to here. Okay, so I'm going to let this warm up for just a couple minutes, and then we're going to take a look at where the local oscillator frequency actually is before we do any more. Okay, just turn the radio down. You don't have to listen to the sound. So you're looking at my SDR radio receiver, and I have a pickup coil. It's near the radio. It's not even in the back of the radio. I put it closer to the back of the radio. There we are. I don't want to influence the radio here, so I'm going to leave it kind of where it was. So you can see the signal kind of coming and going there. I'll point to it with my mouse right here. This one right here. I'm going to figure out the frequency of that. Okay, I'm lining the red line up onto it. Let's get rid of these little numbers here. There. Now it's lined up right on it. So this is the frequency of that peak. That's the local oscillator inside the radio. We should be finding it at 1877. We're finding it at 1875. So that could be because the radio is, I've tuned it to the one extreme as instructed. Maybe it's not quite getting to where it needs to be, or it's gone just a hair too far mechanically. But we want this to be absolutely dead on. Or we want to work with knowledge of what the local oscillator truly is. 1875. So what you do is you take that number, 1875, subtract away 262, the IF frequency. And I'm doing this on my little phone calculator here because I don't trust myself. 1875, that's the local oscillator frequency, and we'll subtract away 262. The radio is actually tuned to 1613. Not 1650, 1613. So now I'm just going to leave this screen for a minute. Okay, now 1613, isn't that what I said? Yes. 1613. So we're going to change the frequency of the signal coming out of my signal generator until we hear it come out of the radio. We'll need a little volume for that. and we'll see if it ends up being the same. Wrong way. It's pretty loud, eh? The radio sensitivity is very good. Watch this meter. Interestingly enough, 1650. Now my signal generator's frequency counter's a little off, so that might actually be 1616. What to think about that? So that suggests the IF isn't dead on the correct frequency. It's a little off itself. But we're talking about a couple of kilohertz here on a car radio. And nobody even looks at the dial very carefully. I think it's okay at this point to carry on. So what is the proper thing to do then? We know the local oscillator is where it is. And I'm going to stop for just a second and change my screen arrangement around, my video screen arrangement. Okay, so now we've got the SDR radio up there. Is the red line really lined up with the white line on the SDR? So I can expand the SDR here. And we'll go a little further. Well, it's really close. I mean, this is, yeah, it's definitely 1875. 262. Well, there's another thing we can do. We can double check the IF alignment just to be sure that this is all making sense. If I just dial it in on the signal generator, it should probably produce a tone from the radio when we get there. Let's give it a try. Well, this is an exceptionally low level signal, by the way, coming out of my signal generator. So the sensitivity of this radio is way up. That's what it appears like. Way up. Way up in the range of communications radios and really good radios. But, you know, not too surprising. It has 3 inductors in it. That's comparable to having 3 sections in the tuning capacitor. So usually small, kind of cheapish radios have only 2 sections in their tuning capacitor. If they have a 3rd, that really improves the operation of the radio, and that's what we've got here. Very good. Okay, so we'll go down to 262 and see what happens here. Probably have to turn up the level quite a bit. Turn up the volume. That's what's missing here. So I'm watching the meter you can't see right now. There it is. It's exactly 262. What cannot be adding up here? Something is not adding up quite right. So you have the IF on 262. We have the local oscillator running at 1875. So again, let me just repeat my arithmetic here. I'm using my calculator so I can less likely to make a mistake. 1875 minus 262, 1613. Again, same number, 1613. Okay. Now we'll turn this way down. control's still dirty. Okay, we're going to try to maximize this gain. $16.15 again on there. Should be seeing $16.13 by, well, it's a little bit of an anomaly. Maybe my signal generator's not so hot. You know what? We can see this signal, 16.15 on the SDR. Maybe the SDR is out of calibration. I'll turn this down here. Okay, so looking again at the SDR, which I've greatly expanded, we're going to shrink it back down. Further, so we're dialed in the signal generator 16.15. 16.15 is right here. There it is. It's right there. The little tiny line you can see right here. I'll get right on top of it. Let's expand out again a little bit. Oh, maybe that's not it. 1603. That can't be it. Okay, with the radio volume down, so we can't hear this, I'm going to pump up the signal generator. I wasn't watching the screen. Yeah, let me try that again. We'll go up even higher. Not visible. Okay, let me move the antenna here. We're in this range. You should be able to see it. It's 16.15. Oh, maybe that's it there. Right here. There it is. Well, 16.16 according to this guy. Now, this thing can be out of calibration by a little bit. It actually has a calibrating adjustment. By the way, where have I got that set? Oh, something funny happened there I wasn't expecting. The shift is set to 60. Let's set it, that may be a problem. Set it to 0. You know, and I'm going to chase myself around in circles because I don't have a standard here to really grip onto. Come on, Ray. Come on, camera. You can focus. Okay, enough going around in circles. We're just going to have to go with it. Okay. What we want to do, since I believe the oscillator we set mechanically with the measurement, this is really just a matter of strengthening things. We have 3 adjustments to do in the radio here. See if I can put the camera like this. Well, you don't have to see the signal generator. It's going to stay where it is. One, 2, 3 screws. Done in that order. So we're going to make sure I've got things maximized here. Just 1 sec. More volume. Stupidly strong signal. Okay, now we're ready. Oh, sorry, looking at the wrong thing there. Look at that meter. Watch the meter. We make the meter go up. But I've done this alignment once already. So if I did it right, there's no way it's going to go up. Okay, I'm going to turn one direction. It jumped up just a touch there before it went down. Go the other direction. We're talking minuscule. These are not the adjustments I'm concerned about. Pushing down on it a little too hard. Splitting hairs too at the same time. Okay, now we'll go after the other adjustment here? No, it's perfectly fine. Perfectly fine. As I kind of expected. It's really these two down here that I'm concerned about. Now, I think we do this at a different frequency. Let me just check here. We tune it to 1,000. And we do J and K. J and K are these outside ones. J is what have they done with it? What's happened? They've rotated us all around. So what are they doing here? So this is upside down from the way the radio is now. So K would be on the left. If you flipped it over, K would be on the right. So that makes this K. That makes this J. That's the way I figured it out last time, wasn't it? It may not really matter which order we do these in. So we go to 1,000 and we do J and K. Okay. Okay. 1,000. Doesn't have to be exact. What has to be exact is the radio has to be tuned to the signal generator exactly. Okay, so we'll tune the radio till we get it. Now watch the meter to get it exact. We're going to look at the SDR and see what it says the local is at. So now the local should be 262 above 1,000. That's easy. Actually, just around 1,000. So that's 1,262. 1,262. So I'm going to force the red line there. 262. And the local oscillator should be right there. Well, it's not. One of those peaks is the local oscillator, so I'm going to tune the radio so we can tell which one is the local oscillator. It's the one that just went to the right side of the red line. So let me turn this back. We have the same sort of thing going on here. Tuning the signal in for maximum again. Again, we're splitting hairs using the SDR like this. The actual local oscillator is at 1258.5. It's about 4 off. Oh, that's because I haven't got this really at a million. I'm just south of a million here on the signal generator. There we go. Now, hey, where'd the local oscillator go? Where'd it go? It's not here. I wasn't watching the screen when I did that. Local oscillator won't have changed. I changed the input frequency. So I should be tuning the radio for maximum. That's it. Yeah, okay. I'd probably be digesting my roast beef sandwich right now, and I don't have as much blood flow in the brain as I might need. Well, that's it, tuned in there. This is the local oscillator. 1280. should be 262. What am I doing way up here? Okay, let me move the pickup coil a little bit here and see if we can really bring in a signal. All kinds of stuff. This is not going very well. I had to tune the radio around and just identify the local oscillator on the SDR. Oh, what's that going way up there like that? What was that? What has happened here? There it is. Well, it comes and goes on the SDR. That's very, very odd. Yeah, the SDR cable, I'm down around the wrong end of things, I think. Yeah, we should be up here at this end. I'll get a stronger signal from up here. Just stick it right here. Now we got a whopper of a signal. Excellent. No question about where it is. Maybe I've been in the wrong spot all this time. So that looks like 1258. Okay, let me reset the signal generator exactly to where I think it should be for 1,000, for a million. 1,000 kilohertz should be there. Didn't seem to make much difference here. We'll zoom in for a closer look. $12.58. Well, I don't quite get it. But let's not let that stop us. I've never let a lack of knowledge stop me before. Come on, camera, you can do it. There, see? Just gotta go down. There's something in view of the camera that's fooling the focus. Don't know what it is, but... Okay, so we'll go JK. We go in here. This one I did not have trouble with last time. Okay, we're set. Now I'm watching the meter over there. Make it as big as possible. Excuse me. Just before I do that, let me just turn the radio and make sure it's right on. Oh. It was not right on. Son of a gun. It's the roast beef. It's erased the coffee effect. There we are. Now, it's even worse. We've gone up higher. It's very important that the radio be tuned accurately at this point. Here we go. We're in. Watching the meter now. Down. I have too much signal coming in here. I just want to make sure that the meter is reacting to the tone. You can barely hear the tone over the noise. Definitely. I'm varying the modulation on the signal generator to do that. So, despite the noise we hear, this has gone way up again. 61. I don't get it. Let's go ahead. Down. Down. this is the one I had trouble with. Okay, we're in. Down. This is an oscillator adjustment. Pretty sure. This is what happened last time. It just wandered off. So this is exactly what happened last time. Since I started adjusting this, it just went cockeyed. Possible I'm pushing on the slug and the thing is rocking like this. So if I push on this other outside slug, oh, son of a gun. So it's rocking and stopping in different angles like this. That's what's happening. So if I tune the radio, where to go? Oh my gosh, it's way down here. That's oh man. This is really, I think it's rocking. Oh gosh. I look through the radio and I push on this a little bit, and you can see the whole mechanism moving around. That's what's doing it. That's what is making this difficult. How do you neutralize that? Let's say tune the radio back and forth a little bit. It should kind of settle into wherever it wants to be. I'll tune this in. This would explain a lot. This would explain a lot about why I'm having trouble with this. So I'm going to assume now that the bar is in it's in the place it wants to be in. You see the local oscillator is way off on the SDR. It's gone way down. 256. So we're at 1,000,000. Should be 1262. Now it's below. Just wander this around a little bit. Tune it back in. SDR says it's in a different spot. What spot is it in? Oh, it's almost right. Let me tune in one direction and back. Tune back. I don't want to go past it. Okay, I think I've got it tuned in. And we see the SDR showing it right on the red line. Now I'm going to tune the other way. Bring it back. Oop, I went a little too far. Pretty much in the same spot. Okay, tuning it right in on the signal generator. Now, I put the red line right on the. Come on, right on there. Stick this tool in. I'm going to watch the SDR and see if just touching this moves that oscillator. Okay, so I'm in. Okay, I'm able to adjust. Watching the meter now. Try my best not to push on it. It's pretty tough. Well, it's pretty much in the same place. See, the local oscillator is hardly changed. I'll go on this side and do the same thing and watch that local oscillator. When I touch the slug, it throws it way off. This is tricky business now. Trying to feel if I'm in the slot or not. No. This is where you end up pushing on it. Okay, I'm in the slot. Are we still on? Local oscillator is stable. Okay, watching the meter. One down. Going up. Going up. Going up. Look at how far I've turned it. Going way up. Way up. Are you kidding me? How's that local oscillator? It's hanging in there. And way up. Way the heck up. One down. I think that's it. I kind of lost my spot. Oh my gosh. Well, that sure seemed to make a big difference. That was a lot of adjustment there. To how much you want to bet anytime this radio's ever been adjusted before, even in the factory, that this rocking thing is a problem. And you know, they didn't have SDRs to look at. They didn't have that. Did not have that. Okay, we got to plug in the antenna here and see how this is really working. So I'm going to take off the signal generator. I'm going to move you away. Extend the antenna a little bit. Antenna to touch any equipment over there. So down under here. Further over. Up there. Let's go up there. Okay, volume is turned down. Plug in the antenna here somehow. Antenna is in. Okay, little radio. What are you going to do this time? You can kind of see the dial here. Let's go see. We want to go towards the number. We want to go the other way. Looking for the French station. Not happening. Going down to 590. here. That might be it right there. Yep, there he is. I recognize the interference signal right on top of it. Okay, with this here, if we look at the SDR, we can double check the IF frequency again. Not the IF. Check the local oscillator frequency and see if it's set for 590. So 590 plus 262. Oh my gosh, that's heavy math. Heavy arithmetic. Okay, I got my phone here. So if we're dialed in at 590, the local oscillator should be 262 above it. Should be 852. 852. Okay, now we're looking up here. This is expanded so we can't see it. 852. Get it on the screen. Here we are. Here we are. So here's where it is, this big thing right here. And the signal is at, whoops, let's try that again. 848. So again, we're just a little out for reasons I don't quite follow. But that might, you know, in terms of close, yeah, it's really close. The only way to know how this is working now is, once again, take it out and set it up in my garage and run it out there and see how it's doing. Because we're going to get nowhere in here with a whip antenna. Okay, wow, that's quite a process. Holy smokes. Okay, we're out here in my garage again, and it's very, very cold. Let's get going. In the meantime, I put the covers on. You know, I did that whole alignment without the covers on. Here we go. I think it's still tuned to 590. Let's find out what happens here. No idea what that interference is, the clicking. But there we are. It's picking up 590. Okay, so my tablet got full there and just quit. So now we're back in business. In the meantime, this clicking sound had gone away, and now it's come back. I have no idea what it is in my house that does this. But nevertheless, ignoring the clicking, good reception on this radio now. Fantastic. Great, that's great.